All right, example 5 is the last example for section 4.3, okay? We're still going to be graphing a parabola, but we're not going to go through all the work that we have been doing, okay? We're just going to talk about how to graph the quadratic function f of x is equal to, in parentheses, x minus 3 all squared minus 10, okay? So pretend you got your test. How would you do this problem, okay? Well, you might think along the lines of what we've been doing in this section, okay? Um, First thought would be, does it open up or down? What's the A, B, and C? Okay. Sometimes when I ask students this, their first response is, if I say, what is the C value here? Talking as in A, B, and C. I get the response that C is negative 10. Okay. And that is not correct. When you look at this function, it is not written as ax squared plus bx plus c. And in order to identify the a, b, and the c, the function has to be written in the format ax squared plus bx plus c. So we need to, distribute here, expand it out, so that we can identify what the a, what the b, and what the c are. Okay, so let's go ahead and do that. Okay, so this is going to be x minus 3 multiplied by itself, okay, and then minus 10, okay. So you can either box or FOIL here, okay. So if you want to go ahead and box this guy, we have x minus 3 and then x minus 3. Make your boxes, okay. So this is going to be x squared, negative 3x, and then negative 3x, and then negative 3 times negative 3 is positive 9. Okay, so over here, when you multiply out x minus 3 times x minus 3, you're going to get x squared minus 3x plus 9. And then you also have this minus 10 sitting out to the side. Okay, so if you combine like terms, your function is x squared minus 6x minus 1. Okay, now it's written as ax squared plus bx plus c. So your a value is 1, the number in front of x is 6, and the constant is negative 1. Okay, so that's the correct way to make the identifications. Okay, so you could go through the process that we've been doing. Okay, you could find the vertex, you can calculate the x-intercepts, the y-intercept, the axis of symmetry, and use all of that to get the graph. Okay, and that's completely correct. However, there is a much simpler way, okay? This function is written in a format that we can recognize transformations, okay? So what you can do, okay, I guess I'll put, before we get to that, I'll put proceed with calculating vertex, intercepts, axis of symmetry. Or you can apply transformations, okay? So when you look at this, you're doing transformations, okay? It's pretty simple to recognize them. Here's our function, okay? The parent function, okay? The parent function here is going to be x squared, okay? And then the minus 3 in parentheses, remember if you're subtracting in parentheses, that's a horizontal shift, and since you're moving, or since you're subtracting, you're going to go right 3, okay, and you want to do what's in parentheses first, so we're going to go right 3, and then the minus 10 outside of parentheses means we're going to then go down 10, okay? So we can easily graph this function by applying those transformations, okay? So I'm going to go up here, and I'm going to quickly jot down the graph of x squared, the parent function. It goes through the origin, 1, 1, 2, 4, okay, so 0, 0, 1, 1, 2, 4, 3, 9. Like I said, you've got to memorize those points for the parent function. And then on the other side, negative 1, 1, negative 2, 4, negative 3, 9. So here's your parent function, x squared. And it's a parabola. Okay. And then what you're going to do is take each point and you're going to move it right 3 down 10. So I'm going to start with the vertex. So right 3 down 10. So that sends the vertex here. Okay. And then you just want to shift all of these points in that manner. So this one you want to go right 3 down 10. This one right 3 down 10. Okay. Right 3 down 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I think that's right. Okay. And then same thing over here. Okay. So all your points will shift and you will end up with this parabola. Okay. Now, regardless of whether you did this with transformations or you did it with the vertex, the intercepts, and the axis of symmetry, you should get that same parabola that I graphed right here. Either way. Okay. All right, that's the end of section 4.3. Remember, the quadratic formula is listed at the very bottom of page 6.